We're beginning lesson 1.4 on polygons. As you can see from our objectives page, polygons, the objectives of this particular lesson, are to define and classify polygons in related terms, practice writing definitions. Again, we want concise definitions, not anything that's too vague, but not anything that's overly precise either. That fine medium. Learn even more vocabulary, because again, geometry is all about the vocabulary. And develop critical thinking and cooperative behavior. All right, let's take a look at our first slide. What is a polygon? So you can look at the characteristics of what makes up a polygon on the left-hand side and the things that are not polygons on the right-hand side. On the left-hand side, we see some familiar shapes, some not so familiar. All right, they're all closed in. There's no open holes or anything like that. Nothing overlapping, nothing crisscrossing, nothing curved. All right, so get an idea loosely of what a polygon is. All right, well, let's move on to the next slide to see a definition. A polygon is a closed plane figure formed by connecting line segments endpoints to endpoints. All right, key there being endpoint to endpoint. There's no overlap. Each line segment is called a side, and each endpoint where the sides meet is called a vertex of the polygon. So what we're looking at is the points themselves are the vertexes. The side plus the vertex plus the other side, that's the angle. You can tell from my lovely picture here, when we talk about consecutive angles, we mean angles that are side by side, and consecutive vertices are points that are side by side. So B is consecutive to C, C is consecutive to D, D is consecutive to E, so on and so forth. A and D, they're not consecutive because they're clear across the polygon from each other. Consecutive sides are the ones that are side by side. All right, they're sharing a common vertex. So consecutive means the next one over. All right, let's clear that up and move to the next slide. We have some ways of classifying and naming our polygons. In order to classify a polygon, we're going to count the number of sides it has. The number of sides is what we call the polygon. That's how we classify it. And then we name a polygon by listing the vertices in consecutive order. Now, it doesn't have to be alphabetical order. A lot of times they're not even going to be in alphabetical order. But whatever I start with, I want to go consecutively. And generally speaking, I tend to go in a counterclockwise manner. So if I were going to name this shape here in the middle, first off, I'd count the sides. So 1, 2, 3, 4, 5. There are 5 sides, which tells me it's a pentagon. So then I would say, okay, that this is pentagon. Let's start with point E. So E, A, B, C, D. So pentagon. I don't have to use a special symbol for pentagon. I would just write it out. E, A, B, C, D. Again, I could have started with any letter as long as I listed them consecutive from that point out. So look over here at the list of vocabulary terms. You are expected to know what these words are. Now, up to an extent. There are some words we don't use quite often. So something like the undecagon, the 11-sided figure, it's not so much popular. Decagon and dodecagon, those are pretty popular. Triangle, of course. Now, triangle is the only one that when we name a triangle, we use a special symbol. Put a triangle in front of it, and then we would say, let's say, for example, if I had D, G, I. I would say that this is triangle D, G, I. So, triangle, 3-sided figure, put a symbol for it. But that point on out, we don't have to worry about it. Quadrilateral means 4-sided. Then pentagon, penta meaning 5. Hexagon, hex meaning 6. Think of the hexagon between elementary and the cafeteria and the dorms in the middle school. All right. Then heptagon, hepta meaning also 7. Where is my mark? Okay. I ceased to write for some reason. Must be losing, there you go. Must have been losing battery or something, who knows. All right, octagon, oct meaning 8. Think of an octopus, it has 8 legs. A nonagon, non meaning 9. Decagon, dec meaning 10. And then let's say we have some figures that don't fit into these special words. Like I have a 25-sided figure. I wouldn't have a weird name for it. I would just call it a 25-agon. All right? And that tells me it's a figure, a polygon, that has 25 sides. So learn these words, and they cleared up for you so you can pause it and copy it down into your notebook. Learn these vocabulary words. Again, you are going to be expected to know most of them. Probably won't see the undecagon too often, probably not the heptagon too often, but if you do see them, you kind of want to be able to recognize them. All right, let's move on to the next slide. Polygon characteristics. So when we talk about polygons, some things that are helpful to us in classifying polygons is talking about the diagonal. And within certain polygons, diagonals have special relationships. We'll get into that later. A diagonal is a line segment that connects two non-consecutive vertices. So if I have, let's say, A, B, and D, C, and D, all right, A is consecutive to B and D, but not to C, so the diagonal goes across. And sometimes you can count up in order to help figure out how, the internal angles. There's a trick using diagonals with that. If it's a convex polygon, all right, a convex polygon is a polygon where no diagonal is outside the polygon. Notice that at any given vertex that I start at, if I draw diagonals, none of them ever go outside the shape. Same thing here with this octagon or hexagon. All right, none of the diagonals ever go outside. Now, a concave polygon. All right, a concave polygon is a polygon that has at least one diagonal outside the polygon. So I have this vertex down here in the corner. All right, here's the consecutive and consecutive. So going diagonally, I have this one here and then this one here. And that diagonal goes outside the shape. Also, think of a cave. You know, you're going into a mountain and you have a cave, all right, it's inside. Or you can also think of, you know, let's say you punch somebody in the stomach and they bowl over, all right? They make a C with their body because they've, you know, flexed in or whatever, all right? You know, they're causing themselves to cave in. So, a violent way to remember that. I don't recommend actually doing that out in the real world. Please don't. But, possibilities. All right, let's take a look at our next slide. Just kidding. There we go. All right, so we have a theorem that says if polygons are congruent, then corresponding sides and angles are congruent. And then notice that the reverse is true. If the corresponding sides and angles are congruent, then the polygons are congruent. Let's say I'm looking at a shape, and I want to prove that it's congruent. Now notice that it didn't say similar. These aren't proportional. These are congruent. Everything about them is exactly the same. And I notice that I have this quadrilateral of A, B, C, D. And I'm comparing it to the other quadrilateral. And AB is congruent to WX. And BC is congruent to WZ. And CD is congruent to ZY. And then AD, or DA, however you want to say it, is congruent to XY. All right? So I've proven that these are congruent to each other using my markings. And so I want to write that they are congruent. So use the equal sign with the little squiggle on top. But when I go to list the second polygon, I have to write it in the order of what's congruent. So if I started with A and went towards B, that means I need to start with X and go towards W. And the reason why is because I need to make sure that the congruent vertices match up. So XW is the side that's congruent to AB. And so then I go down the two congruent sides, so down to Z, and I'm going down to C on the other side. So it's X, W, Z, Y. And that way when I make that congruent, I know looking at this that A is congruent to X, B is congruent to W, C is congruent to Z, and D is congruent to Y as far as the angles are concerned. I know that AB is congruent to XW. I know that CD is congruent to ZW, right? I can just start mixing and matching those points, knowing which ones are congruent to each other. All right? Let's move on. Some special polygons that we have, I've given you a picture, and what I want you to do is I want you to write your own definition of these. Now these pictures are also in your textbook, but the definition isn't. So I want you to write your own definitions, and we will talk about them in class to see how good your definitions were. So an equilateral polygon, let me give you some hints about what equilateral means. All right, there's your hint. An equal angular polygon. And then a regular polygon. Now again, for some of you, you may know these terms already. And some of you, they may be new terms. So spend a moment thinking about what they could possibly mean. Look at the pictures in your textbook, since they're probably a lot neater than mine, and then come up with your definitions. That'll be your homework. All right, that's it for the lesson. So go over those 3 definitions, and then we will talk about it in class tomorrow.